Welcome to this explainer. Today we are diving into a topic that literally saves lives and protects our planet every single day. We're going to talk about the absolute core trifecta of chemical processing: safety, health, and environment, often just called SHE compliance. We'll be exploring exactly how industries manage to balance highly complex and honestly sometimes dangerous chemical processes with the absolute non-negotiable necessity of keeping their workers safe and our environment clean. But before we get into the nuts and bolts of it all, I want you to think about a really crucial question. Who is ultimately responsible when an industrial chemical plant goes wrong? Because when we talk about industrial hazards, we aren't talking about minor inconveniences here. We are talking life or death stakes. We're talking massive environmental devastation, and of course, serious legal consequences. The answer to that question is actually pretty complex. It involves absolutely everyone, from the CEO sitting in a boardroom right down to the individual operator on the floor. And that is exactly why strict, heavily layered compliance systems exist. To see how we manage that massive responsibility, we've broken this explainer down into 5 main areas. 1. The law of the land. 2. Your workplace safety shield. 3. Managing industrial risks. 4. Defending the atmosphere. And 5. Purifying industrial wastewater. Let's jump right in. Starting off with Section 1, the law of the land and the foundations of compliance. I want you to think of legislation as a massive sword, cutting down bad practices. In the chemical industry, mere suggestions just aren't enough. You need rules with teeth. A great example is the National Environmental Management Act, or NEMA, which enforces what's known as the polluter pays principle. It is exactly what it sounds like. It's a legal mandate establishing that the costs of remedying environmental damage and preventing further pollution absolutely must be paid by whoever caused the harm. So if a company causes an environmental disaster, there is no walking away. The state can force them to repair the damage, or the state will do it themselves and send the polluter a truly massive bill. This principle adds huge financial stakes to compliance. It literally turns environmental protection into a bottom-line business necessity. Moving right along to Section 2, your workplace safety shield. This is all about shared stakes on the factory floor. Let's zoom in for a second to the micro level, the individual worker. Safety here is a literal life or death partnership between employer and employee. Under Section 8.2 of the OHS Act, management is on the hook to build the foundational safety shield. They have to provide a safe, risk-free working environment. But it actually goes a lot deeper than that. They have to take proactive steps to physically eliminate hazards before they just slap some personal protective equipment on you. They also have to provide critical information, training, and supervision, and they have to actively enforce these health and safety measures. Turning a blind eye is simply not an option. But wait, here is the flip side, and it's just as important. You, the employee, play an equally huge role in maintaining the shield. Looking at Section 14 of the OHS Act, employees have to take reasonable care for their own health and the health of the people around them. You have to cooperate with the employer, obey lawful rules, and immediately report unsafe situations. Believe it or not, the OHS Act actually makes non-compliance a criminal offense for both employers and employees. It's a true partnership because a breakdown on either side can lead to total disaster. So, how do workers actually know what they are dealing with? That is where HAZCOM comes in. Hazard communication, or HAZCOM, is a set of processes employers absolutely must implement to communicate chemical hazards through proper handling, shipping, labeling, and protective training. Think of it as the ultimate right-to-know tool. It arms workers with the specific knowledge they need to protect themselves against invisible chemical threats. After all, you can't fight an enemy if you don't even know it's there. To communicate those hazards, we used to rely on the old material safety data sheets, the MSDS. And let me tell you, they were the Wild West of paperwork. They were chaotic, they had totally variable formats, and wildly inconsistent detail levels. Trying to find what you needed during an emergency was a nightmare. Well, the new safety data sheet, or SDS, drops the M and brings in some incredible structure. It is now standardized globally into 16 specific numbered sections. Section 4 is always first aid, Section 5 is always firefighting, and so on. This amazing precision means that in a crisis, anyone, anywhere, can find exactly the information they need in seconds. Now, beyond paperwork, we have the physical protocols, like the mechanical lockout procedure. When a machine is being repaired, you absolutely cannot risk an accidental startup. So you follow these exact steps. Step 1, you isolate. Make sure the isolation is done by a competent person. Step 2, apply approved locks and tags. Step 3, and this is vital, discharge all stored energy. Step 4, complete the isolation register. And finally, step 5, perform a bump test to make absolutely sure the isolation is effective. It is a highly sequential protocol designed to literally lock danger out. All right, section 3, managing industrial risks, creating that facility-wide shield. Let's zoom out from the individual worker to the entire facility. How do we manage risk at a macro level? We use the rule of 3 in international ISO standards. These standards seamlessly integrate to form a complete management system. First, you've got ISO 45001. This focuses on occupational health and safety, significantly reducing workplace incidents and building up that proactive safety culture we just talked about. Next is ISO 9001, which looks at quality management, ensuring operational efficiency and making sure we meet customer requirements. And lastly, ISO 14001 handles environmental management, minimizing our environmental impact and reducing resource waste. Together, this trio keeps workers safe, operations incredibly smooth, and the earth clean. Which brings us to section 4, defending the atmosphere, and how we control air pollution. Speaking of keeping the earth clean, how exactly do industries capture harmful pollutants before they ever reach the air we breathe? Well, when fossil fuels burn or chemicals evaporate, we're dealing with two main villains in industrial exhaust. First, physical particulates, and second, toxic gases. Particulates are basically tiny particles of ash and unburned fuel. Think smoke and dust. Then you've got invisible gases, things like sulfur oxides and nitrogen oxides. Dealing with both of these requires some massive, highly engineered physical interventions to grab them before they can escape out of our smokestacks. One of the coolest mechanical interventions out there is the cyclone collector. Let me walk you through how this beast works. First, dirty gas enters the cyclone and is immediately forced to spin rapidly in a spiral. Next, that massive centrifugal force flings the heavy particulates right against the outer wall. Then, those particulates slide down the wall and fall straight into a bottom collector. And finally, the cleaned air reverses its direction and flows right out the top. It is a highly kinetic, intensely mechanical process that quite literally spins the danger right out of the air. But, cyclones can't catch the really, really fine stuff. That's when we bring in the advanced atmospheric defenses. Baghouse filters act just like giant industrial vacuum cleaners, using massive cloth bags to trap fine dust. Then you have electrostatic precipitators, which are fascinating. They actually zap particulates with a negative static electricity charge, which pulls them right onto positive plates. Then there are scrubbers, which spray water or chemicals directly through the exhaust to literally wash the pollutants away. And to stop harmful gases from even forming in the first place, techniques like two-stage combustion lower flame temperatures to prevent nitrogen oxide from combining at all. These engineering marvels are our absolute ultimate atmospheric shield. Finally, let's look at section 5, purifying industrial wastewater, building that biosphere shield. So how do we protect our rivers, lakes, and oceans from contaminated runoff? Well, we have to deal with invisible dissolved toxins, like heavy metal salts that are just too small to filter out normally. So we use a little bit of chemical magic called flocculation. First, a flocculant powder is dissolved into a water tank. Then we slowly agitate this solution with the dirty wastewater. The flocculant forms complex ions that act kind of like magnets, attracting those suspended particles to form heavy clumps. Finally, these big clumps settle to the bottom of a clarifier tank as sludge, which we safely pump away. We're essentially forcing these invisible dissolved toxins to reveal themselves and sink. But what about organic chemical waste? Well, for the grand finale of our environmental shield, we use biological wastewater treatment. This actually harnesses the action of bacteria and other microorganisms to clean water, which is an extremely effective and way more economical alternative to mechanical or chemical processes. Think about that. We are literally teaming up with nature's oldest organisms to clean up some of our most complex human messes. This process, specifically aerobic treatment, acts like a microscopic all-you-can-eat buffet. By pumping oxygen into the wastewater, we create a highly oxygenated environment for these helpful bacteria, who are, let's be honest, nature's ultimate unpaid cleanup crew. These microorganisms completely consume and decompose the organic chemical waste. It's incredibly elegant when you think about it. The bacteria literally eat the toxic waste, and the only byproducts they release are harmless carbon dioxide and water. We are using nature to heal nature. So we have covered a ton of ground today. We've gone from the heavy sort of legislation like NEMA to the physical lockout tags that keep workers alive, all the way down to the microscopic bacteria purifying our water. But at the end of the day, it all boils down to this. Knowing the immense power of these laws and these safety shields, how will you take responsibility for compliance in your own environment? Because remember, safety isn't just some policy in a binder. It is a daily action. I want you to keep that in mind as you head into your next shift. Thanks so much for learning with us today.